Hello everyone, today we shall be continuing our previous topic, that is electricity, and the topics that we are going to take today are: what is the need for constant potential difference? Second one, having said the need for constant potential difference, we will be taking our next topic called circuit. After brief introduction what circuit is, we shall be taking our next topic, current. After current, we shall be trying to take our next topic called Ohm's Law. Okay, let's start one by one. Need for potential difference. Okay, in the previous lecture we have studied about potential and the potential difference, right? Now whenever we speak about the potential difference of any charged body, that means what we are doing, we are linking our potential difference, let's say our potential difference delta V, with our charge on that body. Okay, this charge is not that external charge, this charge is the charge on that body. Let's suppose there is this body 1 having plus 5 coulomb charge, and then let's suppose there is another body 2 having plus 1 coulomb charge. It is so obvious that these two bodies have got some difference of charges. These difference of charges would give the bodies a constant potential difference if we link these two bodies through a conducting wire. Now conducting wire would do what? It would help this body to give out the extra charge so that after some time the system would attain equilibrium. And for the system to attain equilibrium, what we require? We require both of these two bodies to be at the same level. Okay, let's see how these two bodies come at the same level. For that, just consider this one एक अमीर आदमी and consider this one as a भिखारी. Okay, अब इस अमीर आदमी के पास में plus 5 कूलम चार्ज है, इस भिखारी के पास में अभी काफी कमी है चार्जेस की, plus 1 कूलम भी है. अमीर आदमी को दया आई और इसने इसको 1 कूलम चार्ज दिया. जैसे ये इसको 1 कूलम चार्ज देगा, अब हमारे पास क्या बचा? यहाँ पर plus 4 कूलम चार्ज एंड यहाँ पर plus 2 कूलम चार्ज. अगेन अभी भी ये जो आदमी है अभी भी अमीर है और ये आदमी अभी भी गरीब है. वापस से इसने इसको 1 कूलम चार्ज दिया. जैसे इसने वापस से 1 कूलम चार्ज दिया, अब इसके पास में 3 कूलम चार्ज बचा. इसके पास में भी अब कितना हो गया? 3 कूलम चार्ज. जब जिस मोमेंट पे इन दोनों के चार्जेस सेम हुए, उसी मोमेंट पे ना ही कोई अमीर ना ही कोई गरीब, यानी कि दोनों के दोनों बॉडीज ने स्टेबिलिटी या फिर इक्विलिब्रियम अटेन कर लिया. जिस मोमेंट पे इन दोनों बॉडीज ने इक्विलिब्रियम अटेन किया, उसी मोमेंट पे हम बोलेंगे कि अब यहाँ से यहाँ तक या यहाँ से यहाँ तक चार्जेस नहीं मूव करेंगे. अगर चार्जेस मूव करना रुक गए तो इसी चीज को हम लोग टेक्निकल लैंग्वेज में बोलते हैं कि करंट फ्लो करना रुक गया. तो इससे क्या हम लोग एक चीज बोल सकते हैं? इन दोनों बॉडीज के बीच में जो कि अलग अलग पोटेंशियल पर थे, करंट कब तक फ्लो कर रहा है? जब तक दोनों बॉडीज के बीच में कुछ ना कुछ पोटेंशियल डिफरेंस है. इस केस में पोटेंशियल डिफरेंस 4 कूलम चार्ज के हिसाब से होगा, यहाँ पर पोटेंशियल डिफरेंस 2 कूलम चार्ज के हिसाब से होगा. बट यहाँ पर पोटेंशियल डिफरेंस, अब चार्जेस का डिफरेंस क्या है, 0 कूलम, तो पोटेंशियल डिफरेंस भी ऑटोमेटिकली क्या हो गया, 0। जब यहाँ पर पोटेंशियल डिफरेंस नहीं है तो करंट फ्लो नहीं करेगा, इन शॉर्ट चार्जेस ने फ्लो करना बंद कर दिया। ओके, जब ये हमें समझ में आया, इसका मीनिंग क्या हुआ कि जो हम पोटेंशियल डिफरेंस की बात कर रहे हैं, टॉपिक क्या है, नीड, कि जरूरत क्या पड़ी इस पोटेंशियल डिफरेंस की, जरूरत सिर्फ और सिर्फ इसलिए पड़ी कि इस पोटेंशियल डिफरेंस, जब तक दो बॉडीज के बीच में पोटेंशियल डिफरेंस होगा तब तक चार्ज आपका फ्लो करेगा। एंड फ्लो ऑफ चार्ज को जो हमने अपने प्रीवियस क्लासेस में पढ़ा है, फ्लो ऑफ चार्ज इज नोन एज व्हाट, करंट। That means current continues to flow until the point potential difference between the two bodies becomes zero. Until word use किया है यहाँ पर। Okay, ये था हमारा potential difference का नीड, but potential difference तो आपकी bodies के बीच में हो गया, लेकिन constant potential difference कौन सी body देगी? तो constant potential difference का जो हमारे पास इकलौता source होता है, that source for constant potential difference, इस सोर्स को हम लोग बोलते हैं सेल, या फिर कॉम्बिनेशन ऑफ सेल्स हम लोग ले लेते हैं जिसे हम बोलते हैं बैटरी। अब ये हमारे यूज कहां पर आएगा, वहीं पर हमारा सेकंड पॉइंट आता है सर्किट। इलेक्ट्रिक सर्किट मींस व्हाट, जब भी हम किसी स्विच को ऑन या ऑफ करते हैं तो हमारे ऊपर फैन या फिर लाइट ऑन ऑफ होती है, राइट। दैट मींस एक सर्किट कंप्लीट हो रहा है। जब हम इलेक्ट्रिसिटी की बात करेंगे टेक्निकल पार्ट में, सर्किट कंप्लीट होने का मतलब है कि आपके पास कोई ना कोई एक सोर्स होगा, साथ में कोई ना कोई कंपोनेंट्स होंगे। वो सोर्स, अगर हम लोग हाउस होल्ड सर्किट की बात करते हैं तो बाहर से एसी करंट आ रहा है ट्रांसमिशन लाइन से, और वही करंट जैसे हम स्विच ऑन करेंगे तो हमारे फैंस को या लाइट्स को या टीवी को चलाएगा, राइट। सिंपल हम लोग अगर लेबोरेटरी की बात करते हैं, लेबोरेटरी में अगर हमें सिंपल सर्किट बनाना हो तो सर्किट में हमारे पास एक सेल होगा, या तो सेल कह सकते हैं या फिर बैटरी बोल सकते हैं, जिससे कि एक कांस्टेंट पोटेंशियल डिफरेंस मेंटेन हो, लगातार चार्ज फ्लो होता रहे। इस सर्किट में आपके यहाँ पर लेट सपोज कोई एक बल्ब हमने लगाया, ओके, इस बल्ब को हम यहाँ तक लेकर आते हैं, यहाँ पर हमने एक स्विच लगा दिया, ये है हमारा स्विच, this is our bulb. Now what is happening, जब तक स्विच को हम ऑन नहीं करते हैं या फिर जब तक कि ये वाला पाथ क्लोज पाथ नहीं होता है तब तक यहाँ पर चार्जेस फ्लो नहीं करेंगे, दैट मीन्स करंट फ्लो नहीं करेगा। The moment we close this circuit or the moment we have our path closed, in that moment इस सर्किट में आपका करंट, जिसे कि हम I से डिनोट करेंगे, करंट स्टार्ट्स टू फ्लो एंड दिस बल्ब ग्लोज। दैट मीन्स व्हाट इज अ सर्किट? अ सर्किट इज नथिंग बट अ क्लोज कंडक्टिंग पाथ, a closed conducting path for the flow of current which consists of certain electrical components which we have already studied in our class 8, which consist of several electrical components. Okay, electrical components that we have studied already in class 8 include a cell or a battery for constant potential difference. It also includes a key or a switch. Then it includes certain devices or appliances such as bulb or heater. Along with it, if we wish, we can measure our current or potential difference using certain devices known as ammeter or voltmeter. They are also our electrical components, measuring devices. Okay. So, now that we have studied our need for potential difference, now that we have studied what is a circuit, let us discuss our major part where this whole chapter is going to revolve, is going to focus, that is current. Okay. Speaking of which, whenever we say that current is flowing through any device, through any material, that means that material is a good conductor of electricity. All of these conductors, especially metallic wires, these conductors, they look in this way. Okay. Some certain charges from this end enter, then travel through whole conductor and through this end they come out. Okay. If we just take the cross section of this conductor, what we see? We see a certain circular portion, right? This certain circular portion is known as cross-sectional area. So, whenever we speak or whenever we define our current, we need to mention this certain cross-sectional area at any given point. So, current is nothing but rate of flow of charges. This is a broad definition of current, rate of flow of charges. Technical definition of current would be, it is the amount of charge flowing through a given point in given time. Our conductor would look like this. This is any conducting wire. In this wire, your current would be what? Flow of your charges through a given point. That means from this point we are to calculate our number of charges in given time. So mathematically, current is what? Current is total number of charges flowing through a given point of given cross-section area divided by time. Our SI unit of charge is what? Coulomb. SI unit of time is second. So combining this expression, we have SI unit of current as ampere. Giving respect to the scientist who did major work on current, denoted by capital A. Okay. At the same time, let us note down some conditions For continuous flow of current, in any circuit, first condition would be circuit must be complete or circuit should be a closed loop. Second one, a constant potential difference must be maintained across the two ends of the conductor. These are the two conditions which are important for our continuous flow of current through any circuit so that our appliances are lit using the current. Whenever we say that current is flowing in any circuit, so direction of current, this is the positive terminal of our cell or battery, this is a negative terminal. Direction of current is taken to be the direction of your positive charges, but that was the conventional direction. See, earlier what happened? Only protons or positive charges were discovered. After the discovery of protons, current came into picture, and after the current, electrons, which are the transferring part of your atom, they were discovered. So initially, direction of current was taken to be the direction of flow of positive charges or direction of flow of protons. But after the discovery of electrons, we realized that protons could never leave the nucleus. Only electrons could leave the atom and could flow on the upper surface of our conductors. That's why now current is taken to be in the direction of flow of electrons but in opposite direction. Electrons being the negative charge, electrons would be flowing like this and our current would be flowing like this. So whenever we speak of direction of current, conventionally direction of current was direction of positive charges, but according to the modern theory in physics, direction of current is the opposite direction of the flow of electrons. Okay? Fine. Let us discuss a few questions based on our formula I equals to Q by T. Formula will be using I equals to Q by T, and initially in the properties of charges we have already written Q equals to N. These two formulas will be using in these questions. Okay. Let's suppose our question is, if it is known that direction of flow of (3.125 into 10 raised to power 10 electrons is from left to right, in a wire. And let's suppose 10 seconds. We need to find out the value of current along with the direction. Through that wire. Okay. In our question, what is being given? Number of electrons. That means value of n is given. Along with it, what is given? Time. That is 10 seconds. And what they have asked? Value and direction of current. Okay. First, from the number of electrons, let us see how much amount of charge do we have. So, Q equals to Ne. N is what? 3.125 into 10 raised to power 10. E, that is number of electrons. Charge on one electron. Okay, this is our total amount of charge. Alright. If this is the total amount of charge, what we need to do? We need to just substitute this value in this expression I equals to Q by T to get the value of current. Let us solve it further just a bit. Multiply this 1.6 into 3.125. This becomes 5 into 10 raised to power minus 9 coulombs. Okay. So now our current would be what? Q by T. This divided by 10 would give current equals to 5 into 10 raised to power minus 10 amperes. This is the value of current. For the direction of current, what we would see? We would see the direction of electrons that is given to be left to right. If electrons move in the direction left to right, that means our current would be moving just opposite to it, that is from right to left. So our current moves from right to left. This is our answer. Let us discuss one more question. Let us suppose current flows through a conductor for 5 seconds and is noted to be 2 amperes. We need to find out, number 1, total charge through the conductor. Number 2, total number of charges through it. Okay. What we have got our time as 5 seconds. We have got our current as 2 ampere. If we put these two values in our first equation, we would get the total charge through any conductor. I equals to Q by T. Q equals to cross multiply I and T. 10 coulombs. Now, for total number of charges, we would use our second equation, Q equals to NE, which would give N equals to Q by E, 10 upon 1.6 into 10 raised to power minus 19. We have already discussed the value of 1 upon 1.6 into 10 raised to power 19 to be 6.25 into 10 raised to power 18. So our total number of charges become 6.25 into 10 raised to power 19 number of electrons. This is our final answer for part 1 and for part 2. Coming to our fourth point, Ohm's law. Ohm was a scientist. He did major work calculating the flow or nature of current when you change your potential difference. What he did? Nothing. He just took a battery. Along with that battery, he connected a simple heating coil. When he changed the source, that is, whenever he was increasing or decreasing the potential difference from that battery, he noticed that the value of current through that coil was constantly increasing or decreasing correspondingly. So, Ohm's law said that in any conductor, the amount of current flowing is directly proportional to the value of potential difference. But he did what? He kept the material of the coil constant. He kept the temperature and pressure of the surrounding constant. So it has got some limitations. Keeping the surroundings in the sense material of the coil, temperature of the coil and pressure constant. Okay, so our Ohm's law, I is proportional to your potential difference. Furthermore, we will be writing our potential difference as simply V. I is directly proportional to potential difference. For our simplicity, we have reversed this Ohm's statement as V proportional to I. And when we change this proportionality sign, what do we have? V equals to Ri. Here R is nothing but our constant of proportionality, which is known as resistance of any conductor. Okay? On the y-axis, we will be stretching our y. On the x-axis, we will be plotting our V. This will be in volts. This will be in amperes. Okay. Ohm studied that When potential difference was 0, current was 0 in the circuit. When potential difference was increased to 1, current increased 1 time. When potential difference was increased 2 times, current was increased 2 times. Similarly, when potential difference was increased 3 times, current was increased 3 times, and so on. So, finally, the curve that he got was like this. This was a straight line curve, but the slope of this curve, slope is nothing but perpendicular upon base. Slope of this curve was I upon V. And remember our equation from Ohm's law, V equals to Ri. That is, R would be equal to V upon I. So, slope I upon V means this is 1 by R. In actual practice, slope of our Ohm's curve gives G, that is conductance. Property of any material to allow the amount of current to flow through it is known as the conductance. From this equation, we got resistance. Since 1 by R equals to conductance, so resistance is nothing but reciprocal or inverse of conductance. So from here, can we have the definition of resistance? Resistance is nothing but property of any material. Resistance is property of any material because conductance allows the current to flow through it. So resistance being its inverse would restrict or resist the current to flow through it. To resist the flow of current through it. SI unit of resistance would be what? Volt per ampere, and it is called nothing but ohms, denoted by this sign. This is our SI unit of resistance. This Ohm's law or this curve is applicable only for ohmic conductors. Ohmic conductors means all those conductors or materials which follow this Ohm's law. That is, as we are increasing our potential difference, in accordance our current would be increasing proportionately. This is followed by ohmic conductors. So all your metal conductors, that is copper wire or aluminium wire or any silver wire, all those wires are our ohmic conductors. Having talked about ohmic conductors, there must be something called non-ohmic conductors, that is those materials which do not follow Ohm's law. Those materials in which our current does not vary proportionately to voltage. Sometimes it may happen that with increase in voltage, current could decrease, or sometimes it may happen that with increase in voltage, there is a sharp increase in the current. Those materials are called non-ohmic conductors. Example of non-ohmic materials are your diodes or transistors or rectifiers. But we need not to be bothered about it. It is not in our syllabus. Okay. So, we shall just conclude our chapter for today here only with ohmic conductors. Today we have also learned about one important property known as resistance of any conductor. In our next class, we shall be discussing again the resistance and other factors on which this resistance depends. Along with it, we shall be taking a few more questions and we shall be switching on to combination of resistances. That be all for today. Thank you.